We now find the second and third derivative of this function y of r. This is given as 4 by 3 pi r power 4. So first we have to find its first derivative. So I find the first derivative and this is written as y prime of r, and this equals on the right side we have 4 by 3 pi r power 4. So here we can consider this quantity, that is 4 by 3 pi, as a constant. So when we apply the constant multiple rule, this becomes 4 by 3 pi times of, we just have to find the derivative of r power 4. So when we use the power rule, we put the power in front, that is 4, and then write down r to the power of 4 minus 1. And this equals 4 r power 4 minus 1 is 3. So it's basically 4 r power 3 is the derivative of r power 4. We can simplify this by multiplying this 4 with 4. So therefore this becomes 16 pi by 3 r cube. And this is the derivative of y of r. That is the first derivative of y of r. Now let's find the second derivative by differentiating both sides with respect to r. So then we will get y double prime of r, and this equals once again we have to apply the constant multiple rule, and when we do that, we keep the constant, that is 16 pi by 3. We keep the constant as it is, and then multiply with the derivative of r power 3. The derivative of r power 3 using the power rule, we put the power in front and raise r to the power of 3 minus 1. So this equals 3r squared. So I write down 3r squared here. Now we see that we can cancel this 3 with this 3, so they get cancelled, and therefore this equals 16 pi r squared. This is the second derivative of the function y of r. Now let's find its third derivative by differentiating this y double prime of r. So we can write down y triple prime of r, which is the third derivative of the function y of r. And this equals, once again we apply the constant multiple rule. So therefore the constant remains as it is. And then we have to find the derivative of r squared. And derivative of r squared, once again we use the power rule. So I put the power in front and then raise r to the power of 2 minus 1. And this equals 2 minus 1 is 1. So it is basically 2r power 1, which is nothing but 2r. So I put 2r, which is the derivative of r squared. Now we can multiply this, and that is 16 times 2 is 32 pi, and then we have r. So this is the third derivative of the given function y of r. Let's answer this question. So in this question, we are given the equation of a motion of a particle, which is given as s of t equals 2t cube minus 7t squared plus 4t plus 6. And we have to answer these three questions. That is, we have to determine the velocity function, acceleration function, as well as the acceleration at the first instant when the velocity is 0. So first, let's determine the velocity function. So this s of t basically represents the position function. And v of t, that is the velocity function, this is basically the derivative of the position function. So we can write down this as d by dt of s of t. Now let's replace the position function, that is it's the derivative of the position function is 2t cube minus 7t square plus 4t plus 6. Now let's find the derivative of this. So we have to find the derivative of each of the expression. That is the first expression, or the first term is 2t cube. So here we have to apply the constant multiple rule, so that we keep the 2 as it is, and then find the derivative of t cube. And derivative of t cube using the power rule is 3t squared, because we have to put the power in front and raise t to the power of 3 minus 1, which is 2. So therefore this equals 3t squared. And now I find the derivative of the next term, that is negative 7t squared. So I put the constant negative 7 as it is, multiply with the derivative of t squared, which is 2t when we apply the power rule, and plus Once again, I apply the constant multiple rule to keep the constant 4 as it is, and then find the derivative of t, that is 1. So let's simplify this. 2 times of 3 is 6, so this is 6t squared, and negative 7 times of 2 is negative 14t plus 4. So this is the function which represents the velocity, or this is the velocity function. Now let's determine the acceleration function. So acceleration function is basically the derivative of the velocity function. So we write down a of t, which represents the acceleration function, and this equals the derivative of velocity function, that is d by dt of v of t. So I'm going to replace v of t, which we found in part A. This is part A. So this is 6t squared minus 14t plus 4. Let's find the derivative of each of the terms. So first I find the derivative of 6t squared. I put the 6 as it is, and then multiply with the derivative of t squared. Derivative of t square is using the power rule, it is 2t. So I put 2t here, minus 14 times of derivative of t is just 1, and derivative of 4 is a constant. So we put, the derivative of 4, which is a constant, is a 0. So it is 0. So therefore, this equals 6 times 2 is 12t minus 14. So this is the acceleration function. And so this answers part B. Now let's answer part C. In part C, we have to determine the acceleration at the first instant when the velocity is 0. So we have to basically put velocity equals 0, determine the time, that is the first value of time, and then we have to find the acceleration for that corresponding time. So let's see how to do this. So first I'm going to consider the velocity function, and I'm going to consider, or I will replace the velocity function as 0. So first let me copy that, that is 6t square minus 14t plus 4. Now we have to replace velocity equal to 0, because we have to determine the acceleration at the first instant when the velocity is 0. So I put velocity equal to 0. This equals 6t squared minus 14t plus 4. We can factor out the common term from all the three terms, which is 2. When we do that, we get 2 times of 3t square minus 14 divided by 2 is 7, so it becomes 70, and 4 divided by 2 is 2. So we get this expression. Now we divide by 2 on both sides. So this is essentially 0 equals 3t square minus 7t plus 2. Now this is a quadratic equation, which we can write down as a product of two linear terms. That is, we will put 3t. We should have 3t squared. So another linear term will be t. And then we should have negative 7t and positive 2. So I put a negative 1 and negative 2 here. Let's cross check. This is 3t times of negative 2 is negative 6t. 3t times of t is 3t square. Negative 1 times of t is negative t. Negative 1 times of negative 2 is positive 2. So we have 3t square. This is minus 7t, and this is plus 2, which is what this expression is. So it is perfectly correct. Now we equate this to 0. Now we have a product of two terms, which means either one of the terms is 0. So this becomes 3t minus 1 equals 0, or t minus 2 equals 0. So from this, we can solve for t by adding 1 on both sides and dividing by 3. So we get t equals 1 by 3. And here, if we add 2 on both sides, we get t equals 2. So now we have to determine the first value of t, which comes on the number line. So if we plot this on the number line, let's have this 0. This is t. T equal to 1 by 3. This is approximately 0.33. So we will have 0.33 over here, and then this is t equal to 2 here. So point 0.3 comes first, then the t equal to 2. So this is the first instant when the velocity is 0, which means we have to consider t equals 1 by 3. And for this t, we have to find the corresponding acceleration function. So that will answer the question. So let's determine that. Now let me take this acceleration function and substitute t equal to 1 by 3. So therefore this becomes a of 1 by 3, and this equals, we have the acceleration function 12t minus, it is 14. So let me first copy the acceleration function. This is a of t equals 12t minus 14. So I'm going to replace t equal to 1 by 3 here. So therefore this becomes 12 times of 1 by 3 minus 14. 12 goes into 3 as 4 times. So this equals 4 minus 14, which equals negative 10. And the unit of this is meter per second square, which is the unit of acceleration. So we have determined the acceleration, uh, which equals minus 10 meter per second square when the velocity is 0. That is at the first instant when the velocity is 0.